Hey, welcome to the Earth videos. So, Earth obviously is the planet we know the most about because we're on the planet. We don't have to send probes there to study. So, literally, this whole course, this whole year could be taken up by talking about Earth, and we still wouldn't cover everything. But that is usually reserved for a class such as geology or Earth science. I'm just going to briefly talk about Earth, mostly so that we can compare other planets to Earth. A lot of what we know about other planets, or what we come to theorize about other planets, is based on what we know about Earth. Um, Often call it comparative planetology, or other ways of saying it. But basically, we use what we know about Earth to help us determine what goes on other planets, because we make the assumption. It's may or may not be a perfect assumption, but it is one of the better assumptions we have. We use the assumption that the planets form in similar ways. The planets came from the same original clump of stuff in space, and other things, they all experience gravity in the same way. So um, a lot of things can and probably should happen similarly um, through all the planets. Yet we see so many differences between the planets. So obviously things must be different as well. So it's not the perfect way to look at it, but it is a very helpful way. So again, to summarize, I'm not going to talk a lot about Earth because you could take an Earth science class and learn all about Earth. But I'm going to talk about the basics and actually reference back to Earth a lot as I talk about the other planets, which you've already seen in the Mercury, in the Venus, and also in the Mars videos. I've referenced Earth a lot. So with that in mind, let's just kind of go through Earth real quick. It is our home. It's an ocean planet. Most of the surface is covered with ocean. A lot of water on Earth, a lot of liquid water. It's one of the larger of the inner planet. It's the largest of the inner planets, but it's one of the larger of the terrestrial, rocky, solid sort of planets versus the gas giants out in the outer part of the solar system. They're much bigger than the Earth, but they are just big clumps of gas, really thick atmospheres. But we're going to talk more about that next. So yeah, it is the largest of the inner planets, but not that much larger than Venus. Venus comes in a close second, as you remember. It's a bit more massive than Venus, 6 times 10 to the 24 kilograms. Slightly larger radius than Venus, 6,400 kilometers on average, and similar density to Venus, 5,500 kilograms per cubic meter. But that's an average density, as we're going to talk about as we talk about the inner parts of the Earth. The densities there vary, and so this is the average of all of the layers of the Earth, of the inside of the Earth. Earth's atmosphere. So we spend a lot of time in the atmosphere. We have these crazy devices that we invented, I guess a bit over 100 years ago, called airplanes. Before that, we just basically, looked at the birds in envy and like, oh, how do they do it? And we had hot air balloons, probably. I don't know how long those have been around, but in terms of planes, the Wright brothers started it all back, I believe, in the early part of the 1900s, or maybe even, yeah, I'd have to look it up. But it hasn't been that long in the history of humans that we've been flying around in this part of the atmosphere. Although there's a lot more of the atmosphere that planes don't work that well in, but we got other probes going on up in this area. Anyway, so we know a lot about the atmosphere, and we can use that to compare to the other atmospheres. For example, in the Venus videos, I had this side by side next to Venus's profile, atmospheric profile, to show you the comparison. You remember Venus's atmosphere is much thicker, much deeper, etc. But Earth's present atmosphere looks like this. Was it always like that? Where did our current atmosphere come from if it wasn't always like that? Well, using comparative planetology, most likely all the planets were forming from the same stuff out in space, the same material, and um, a lot of that material was hydrogen and helium, mostly hydrogen and a good amount of helium. And that makes sense because our sun is mostly hydrogen currently, although it's burning that hydrogen in the core into helium, fusing it together, but we'll talk about that next semester. So one possibility is that early on, as the Earth was forming, it was gravitationally holding in hydrogen, helium, methane, ammonia, water vapor, a lot of the things that we typically see in nebula. What's a nebula? It's like a gas and dust cloud out in space that often they are the stellar nurseries. Stars form in there as gravity collapses these nebula clouds down into more solid objects. So based on that, it's a good probability that Earth's early atmosphere was made out of this stuff. But since the Earth is kind of relatively tiny in the grand scheme of things, it's not as big as the gas giants, so it wasn't able to hold on to the really light elements, especially the lightest, hydrogen and helium. So those most likely escaped early on, except for whatever was locked in to other things, like a lot of the hydrogen would have been locked in the water vapor. And then as the Earth cooled and started, becoming more similar to how it looked today, but still pretty different way back then, there would have been most likely a lot of volcanic activity, and there's evidence for that. And so this volcanic activity would obviously spew out magma, lava, basically molten liquid rock, but a lot of gas would have escaped as well. And it's thought that all the nitrogen that we have now, or much of the nitrogen that we have now, would have come from this outgassing of volcanic activity, in addition to more water vapor helping form the oceans. Although another theory is that a lot of the water that we have came from asteroids and comets, and just a lot of the early collisions that bombarded our planet in the past. Some methane would have escaped, carbon dioxide would escape, sulfur dioxide. Although, as we discussed in Venus, most likely this happened. These same two early steps happened in Venus, but for some reason, well, most likely because Venus is closer, but probably for other reasons that we're not aware of as well. The carbon dioxide in Venus didn't dissolve in the oceans because Venus was too hot to keep the water as a gas, as a liquid. And so you see a lot more of this in the atmosphere, whereas on Earth, most of it dissolved in the oceans, and leading to this tiny amount of carbon dioxide relatively we have today. And so the nitrogen is still around. We have this new thing, oxygen. Where did that come from? Well, plants really like carbon dioxide. They take carbon dioxide and use sunlight and take the carbon out, use the carbon and use that to make their plant material, carbon in the cells and all that. I'm not really super knowledgeable about biology because my last biology class was in high school, but this is basically the photosynthesis process, taking carbon dioxide and sunlight and turning it into oxygen. It's thought that this is where most, if not all, of our oxygen would have come from. And then, of course, just a little bit of trace elements, including varying amounts of water vapor, depending on whether you're, measuring in the desert or in maybe the tropical rainforests. But still, relatively small amount of water vapor compared to nitrogen and oxygen. So yeah, it's thought that these are the three main phases of evolution. This is kind of like the birth, infancy. This is kind of like adolescence, and this is kind of like adulthood in terms of the Earth's growth of its atmosphere. But the atmosphere, it doesn't really. It's tiny compared to how big the Earth is. This is a picture taken from the space station, and as I play this, I'm gonna show you. We're going to compare where we are over the East Coast. This is basically flying over the East Coast right now. We're looking at the Gulf of Mexico. Here's Florida here. But as you're flying through, and as we look at the city lights and compare, which is kind of cool, also check out how thin the atmosphere looks. It's just this little layer, and you can see the top boundary. And this is all that we have protecting us from the vacuum, the cold vacuum of space, is this thin layer. And whatever we put into it, aside from what's already there, that list that I had before, uh, that's where it goes. It stays there. So we gotta kind of take care of our atmosphere. But anyway, let's play this. And again, you're also gonna see once we hit the northern parts of the United States, the East Coast, you're gonna start to see northern lights in the atmosphere, which is pretty cool. So let's play this here, and I'll pause it periodically. So we're flying over. Looks like we got Louisiana, New Orleans here. You can see New Orleans going into Florida down here. I'm guessing this is going to be Atlanta coming up. And then above Atlanta, you got a nice big park area, so you're going to see some darkness, some non-human civilization. See all that? It's pretty cool. You could go hiking in here, I'm sure. A lot of good hiking. But right below that is Atlanta. What else we got going on here? Charlotte is probably like right one of these three. You're almost able to start to see the northern lights here as well. But again, look how thin the atmosphere is. And look how much of a presence we have on our planet. I mean, we're everywhere. Literally everywhere. We're not in the oceans yet. Maybe that's where we'll need to go there at some point, but live on floating barges. See if we can find where we are. DC must be coming up soon. Yeah, so if I pause it here, we got, looks like Delaware, and this kind of branch below is probably this right here. So we must have like Richmond, DC, maybe Philadelphia up here. And look at the nice, beautiful northern lights coming up. Whoa, pretty. You can see some clouds kind of distorting the light below. This is Massachusetts up here, Cape Cod, Boston around here. Like, we're plastered on the East Coast, just humans everywhere. Of course, getting up to where I grew up is not much at all. I grew up in northern Maine here, and that's pretty dark. It was lonely up there. Quebec City probably, so like around here somewhere. And oh, beautiful northern lights. And you can see they kind of go up above the atmosphere as well. We're going to talk a little bit about that. Northern lights come from the Earth's magnetic field interacting with the solar wind. You can see the solar activity, magnetic activity, or whatever you want to call it, going on up here. It's beautiful. But yeah, again, long story short, look how thin the atmosphere is. It's pretty crazy. So that's good for this video. We're already at 13 minutes. Next video, I'll start talking about the inside of Earth, much thicker layer, mantle, core, and all that. So until then, see you next time.